Okay, audience profile data collected at the ESPN Sports Zone website showed that 26% of the users were women. Assume that this percentage was based on a sample of 400 users. What is the 95% confidence interval for the population proportion of ESPN Sports Zone website users who are women? Okay, I noticed that they're asking for a confidence interval here, a 95% confidence interval. And the two types of confidence intervals we have are averages and proportions, and this one is talking about proportions. So I'm going to be looking at a confidence interval of the form P bar, the sample proportion, plus or minus Z alpha over 2. There is no t-distribution when talking about proportions, and the standard error formula is the square root of P bar times 1 minus P bar all over the sample size. So I've got to collect this information from the problem. This one gives me the sample percentage directly as 26%. No calculation needed there. The other thing is sample size, and that is 400. The Z alpha over 2, alpha is going to be 0.05. Since I have a 95% confidence interval, and then alpha over 2 then is 0.025. And there are only a few values that we would use here, and I remember this one is 1.96. Okay, so let's plug everything into the confidence interval. So we'll have 0.26 plus or minus the 1.96 times the square root of 0.26. It's my sample proportion, and then the complement of that is 0.74. Then divide by the square root of 400. So I'm taking the square root of that whole thing. I'm going to go ahead and calculate the margin of error, and that turns out to be 0.043. So this one is my margin of error, 0.043. And what does that mean, actually? Well, that if we were going to estimate the population percentage of ESPN Sports Zone website users that are women, we would estimate that percentage at 26%. But how far off could that 26% be from the real population proportion who's using that website that are women? Well, according to the margin of error, that could be as far off as 4.3% under a 95% confidence. So to build our confidence interval, we have an estimate of 0.26 and a margin of error at 0.043. So we'll add and subtract that margin of error from our sample percentage, and we'll get our confidence interval from 0.217 to 0.303. So there is a 95% probability that the true population percentage of women using this site is somewhere between 21.7% and 30.3%. So this would be what I would call the interpretation of the confidence interval. In other words, you're explaining what the confidence interval is telling you in the context of the problem. So this problem was a confidence interval for proportions. And the way I recognized it was that, first of all, the problem was asking me for a confidence interval. There are two types of confidence intervals, one for averages and one for percentages, and this one was for percentages. And the problem's going to have to give you that information. So right away I knew that the formula I was going to use was going to be this one, where I would have to get a sample percentage. And for percentages, I'm always using a standard normal distribution for those, so there is no t-distribution. If this was averages, I would have to make a decision about that, but not with this one. Also, keep in mind that confidence intervals are confidence intervals, and they pretty much are structurally the same thing. The difference with percentage confidence intervals is you have a different standard error. The standard error for percentages is the square root of the sample percentage times its complement divided by the sample size, the square root of that whole thing. So be careful and make sure that you know how to calculate that correctly.